Lightricks just open sourced LTX-2.
Thank you, Sylvia. And yes, this is a sentence I never thought I'd say on live television. But this morning, here in the quiet town of Newcastle, Vermont, black gold has been found. If my cameraman pan over, you'll see what all the excitement's about. There it is, folks! The moment Newcastle will never forget!
A brand new audio and video model that creates 20 seconds of smooth, synchronized audio-visual content at full HD quality, runs 18 times faster than competing models, and gives you complete sound and visuals in one unified system. And the crazy part is, they released the entire thing for free. Full weights, training code, everything. While OpenAI keeps Sora locked behind waitlist and Google limits view access, Lightricks just handed the whole industry a working audio plus video model that anyone can download and run today. So let's talk about it. Alright, so LTX-2 was first announced on 23rd of October 2025, but the full open source release with model weights dropped on January 6, 2026. The moment the weights became available, developers started pulling them and running tests. This is not some tiny research project. Lightricks is the company behind Facetune and VideoNet, apps with over 730 million downloads worldwide. They have been building AI tools for creators for years. But this time, instead of keeping their tech behind paywalls, they decided to go completely open. The model file sits on Hugging Face right now. Anyone can grab it. No API limits, no users fees, no permission needed. Here is the thing. LTX-2 is not just a video model. It's an audio plus video model. That means it generates synchronized sound and visuals at the same time from a single text prompt. You type a description and it creates a video with speech, background sounds, music, Foley effects, all perfectly timed to match what's happening on screen. This is a huge deal because most video models out there right now stay completely silent. They only create visuals. You have to add sound separately using a different system. But LTX-2 handles both in one unified process. The model has 19 billion parameters total that's split into two streams. The video stream has 14 billion parameters and the audio stream has 5 billion parameters. This is called an asymmetric dual stream architecture. Video needs more processing power because it's way more complex. It has to handle spatial details, motion, lighting, and timing all at once. Audio only needs to handle temporal information, meaning sound over time. So Lightricks gave video more capacity and kept audio lighter. This makes the whole system more efficient. Now, here is where it gets interesting. The two streams talk to each other constantly through something called bidirectional cross-attention. That means the video stream can look at what the audio stream is doing and the audio stream can look at what the video stream is doing. They influence each other throughout the entire generation process. This is why lip sync works so well. The audio knows what the mouth is doing on screen and the video knows what sound is being created. They stay locked together. The architecture is built on something called a diffusion transformer or DIT. That's the same foundation used by Sora and Stable Diffusion 3. But Lightricks made some smart changes that let the model run faster and handle larger videos without breaking apart. The base version generates 121 frames at 25 frames per second. That gives you about 5 seconds of video. But the extended version pushes all the way to 257 frames, which is roughly 10 seconds. And when you add in multi-scale, multi-tile inference, the model can stretch up to 20 seconds of continuous synchronized audio and video. The numbers back this up. On a single H100 GPU, which is NVIDIA's top-tier chip, LTX-2 generates one denoising step in just 1.22 seconds. Compare that to 2.2, which takes 22.30 seconds per step. That's 18 times faster. Even OV, another open source audio video model, is slower. And the speed advantage gets even bigger at higher resolution and longer durations because of how the model handles memory and processing. But speed means nothing if the quality is bad. So Lightricks tested LTX-2 through human paired studies. They compared it to both open source and closed models. The results showed that LTX-2 is the best open source audio video model available right now, and it performs close to pro-parity systems like VEO3 and Sora 2. On Artificial Analysis public rankings as of November 6, 2025, LTX-2 ranked 3rd in image to video and 4th in text to video generation. That puts it ahead of some big pro-parity systems like Sora 2 Pro and large-scale open models like 2.2. Let me break down the technical piece because this is where LTX-2 really shows its strength. The model uses separate encoders for video and audio. Video gets encoded by a spatio-temporal causal VAE that compresses frames into a latent space. Audio gets converted into mil-spectrogram at 16 kHz, then encoded by a separate causal audio VAE. These latent representations are what the model actually works with during generation. Using separate encoders is smart because video and audio have completely different properties. Video is 3D with width, height and time. Audio is 1D, just time. Forcing them into the same space would waste resources and hard quality. The video stream uses 3D rotary positional embeddings or rope that injects positional information along spatial and temporal axes. It knows where things are in the frame and when they happen in time. The audio stream uses 1D rope which only tracks time. But during the cross-attention layers, only the temporal component is used. That forces the two streams to align on timing, not spatial position. This is how the model keeps everything synchronized down to the sub-frame level. Each dual-stream block performs 4 operations in sequence. First, self-attention within the same modality. The video stream looks at other video tokens and the audio stream looks at other audio tokens. Second, text cross-attention for conditioning on the prompt. Third, audio-visual cross-attention where the two streams exchange information. And fourth, a feed-forward network that refines the feed. Throughout all these operations, the model uses cross-modality add-along gates. That means the scaling and shift parameters for one modality are conditioned on the hidden states of the other. This helps the model synchronize audio and video features even when their diffusion time steps or temporal resolutions differ. The training process is another major part of the story. Lightricks trained LTX-2 on 20 million video clips. That's a massive dataset. Each clip had detailed text captions that described both the visual and audio tracks. They built a new captioning system specifically for this. The captioning system captures accents, appearances, camera motion, lighting, speech transcription with speaker identification, language detection, accent recognition, music, ambient sounds, and foley effects. The captions are comprehensive but factual. They only describe what's seen and heard without emotional interpolation. This level of detail helps the model understand connection between words and audio-visual content. For example, if the prompt says a man claps his hands twice, the model knows what clapping looks like visually and what it sounds like. It can generate both and keep them perfectly aligned. If the prompt says a woman speaks in French with a partial accent while standing in a busy cafe, the model generates French speech with the right accent, background cafe noise, and visuals that match the set. Now let's talk about what LTX-2 can actually do. The model handles text to audio video generation, which means you type a description and it creates everything from scratch. But it also supports image to video, where you upload a picture and the model animates it with synchronized audio. You can even do video to video tasks, where you upload existing footage and the model changes the style, adds new elements, or modifies the audio track. One of the most interesting features is the modality-aware classifier-free guidance, or bimodal CFG. During inference, you can control text guidance and cross-modal guidance separately. Text guidance controls how closely the output follows your prompt. Cross-modal guidance controls how much the audio and video influence each other. If you increase cross-modal guidance, the synchronization gets tighter, lip sync improves, flawless sounds match accents more precisely, and the overall audio-visual coherence gets stronger. For all their reported results, Lightricks used text guidance of 3 and cross-modal guidance of 3 for video, and text guidance of 7 and cross-modal guidance of 3 for audio. The audio quality is another standout feature. The model generates stereo audio at 24 kHz sample rate. That's high fidelity output. It handles speech, music, ambient sounds, and foley effects all in the same generation pass. The audio VAE produces a concept 1D latent space where each token represents about 1/25th of a second. After generation, the latents get decoded back into stereo mil spectrograms, then passed through a hi-fi GAN vocoder that reconstructs the final waveform. The vocoder was modified to handle joint stereo synthesis and upscaling from 16 kHz to 24 kHz. For high resolution output, LTX-2 uses a multi-scale, multi-tile inference strategy. It starts by generating a base latent representation at lower resolution, around 0.5 megapixels, that establishes the global scene composition, motion dynamics, and audio-visual synchronization. Then a dedicated intent upscaler increases the spatial resolution while maintaining temporal consistency. Finally, the upscale latents get partitioned into overlapping spatial and temporal tiles. Each tile gets refined independently using the same model parameters. This allows the model to synchronize fine details like skin textures or environmental elements without exceeding GPU memory limits. The tiles get blended in the latent space to ensure smooth transitions before final decoding. This entire process enables full HD 1080p generation. But here is the part everyone needs to hear. LTX-2 is not perfect. It still struggles with certain things. Performance varies across languages. Prompts in languages or dialects that were underrepresented in the training data may reduce less accurate speech synthesis or weaker audio-visual alignment. In multi-speaker scenarios, the model can get confused about which characters should speak specific lines. It might assign spoken content to wrong person on screen. The model also has limitations with temporal scope. Generating coherent audio-visual sequence longer than roughly 20 seconds can lead to temporal drift, reduced synchronization, or less diverse scenes. The quality starts to degrade, and because LTX-2 is a generative diffusion model, it doesn't have explicit reasoning or word model capabilities. It can't do deep narrative coherence or factual grounding on its own. Those depend on external systems like large language models, the conditioning text. To be clear, these limitations are not unique to LTX-2. Every audio-video model deals with them. Every proprietary system struggles with long-form consistency and multi-speaker attribution. But because LTX-2 is open source, developers can see exactly where the problems are and work on fixing them. That's the whole point of open sourcing. The community can improve the model faster than any single company could. Now let's talk about the text conditioning, because this is crucial for speech quality. LTX-2 uses Gemma 3, a 12 billion parameter multimodal text encoder. This is a decoder-only language model with causal attention. But causal attention has limitations. For conditional generation, it only looks backward in the sequence, not forward. To fix this, Lightricks added two refinement stages. First, they use multi-layer feature extractor. Instead of only using the final layer output from Gemma 3, they extract features from all decoder layers. These intermediate representations capture a hierarchy of linguistic meaning. Early layers handle raw phonetics, and later layers handle complex semantics. All these features get projected into a unified embedding space using a learnable metric. This gives the model much richer conditioning than a single layer approach. Second, they introduce thinking tokens. These are learnable tokens that get appended to the text embeddings before they go into the diffusion transformer. The thinking tokens go through bidirectional transformer blocks that refine the text representation. They act as global information carriers, aggregating contextual details and filling in missing information. This helps the model generate speech that not only synchronized with lip movement but also natural in cadence, accent, and emotional tone. The text connectors are trained together with the main audio and video blocks. The inference performance is one of the biggest advantages. LTX-2 generates up to 20 seconds of continuous synchronized audio-visual content. That exceeds Veo 3, which maxes out at 12 seconds. It also exceeds Sora 2, which goes up to 16 seconds. OV, the other main open source audio-video model, only handles 10 seconds. And 2.5, which is video only, also stops at 10 seconds. So LTX-2 not only runs faster, it also handles longer sequences than almost anything else out there. The technical report also revealed some interesting training details. They used wave prediction instead of standard noise prediction. This is a technical change in how the model learns, and it helps generate cleaner images with better color accuracy. The model was also trained on multiple aspect ratios at the same time, which gives it flexibility for different video formats. Most video models are trained on one fixed size, like 16:9. If you want a different shape, the model struggles. LTX-2's multi-aspect ratio training makes it way more useful for real-world projects where you need different formats. The team also built a custom inference pipeline that supports batching. That means you can generate multiple videos at the same time on the same GPU. If you are running a content studio and need to produce hundreds of videos, batching cuts the total time down significantly. Most open source models don't support these out of the box. The bigger picture here is that audio-video generation is following the same path as image generation. 2 years ago, only closed models like Dolly, and Mid-Journey could create good images. Then stable diffusion came out and changed everything. Now anyone can run image models locally and fine-tune them for specific needs. LTX-2 is trying to do the same thing for audio-video, and if it succeeds, the shift will be just as big. That's where we will wrap it up. One thing I'm curious about is how fast the community will improve this model. With full access to the core and weights, we could see major upgrades in the next few months. Drop your thoughts below. Make sure you are subscribed, hit the like button, and I will see you in the next one.